Did anybody get a chance to go to this VOR simulator website and play around with it a little bit?
I tried. It was too complicated, and I gave up.
I'll kind of explain it just a little bit before I get into the assignments. This, if you're able to use it, it's definitely, once you've figured it out, it's a good resource because it shows you how the VOR works.
So let's take a look at how the VOR receiver indicates. So we can see in the airplane we have the VOR receiver, and the OBS knob will allow us to select different courses off of the VOR station. So what's happening here is as we're rotating the dial, we're selecting different courses. Here we selected the 360 degree course. So a line flowing 360 degrees through the VOR station. Now radials are always named in the direction that they're located from the station. So if I was north of the station, I'd be located on the 360 degree radial. If I was over toward the east, this would be the 90 degree radial, the 180, the 270. So where we started, we are somewhere on the 230 degree, approximately 230 degree radial, southwest of the station. Now, the VOR receiver doesn't care which way the airplane is facing. You can see as I rotate the airplane, the indication remains the same, a right-hand needle deflection with a 2 indication. The way it will create that indication is with an interpretation based on the aircraft's direction being identical to whatever course that you've selected on your OBS. So it's imagining if the airplane was facing north, that the radial that we selected, the course we selected, would be off on the right-hand side, hence the right-hand needle. Now the 2 indication shows us that if we were flying this way, we would be going toward the dividing line. And once we would cross that dividing line, we'd now have a from indication. If the airplane was located over here, we can see going in that 360 degree direction, the airplane would have the course off on its left-hand side, the radial over here on its left-hand side. And so, again, it doesn't matter which way you're facing. You could be facing any direction. It's going to indicate as if you were facing 360 degrees, what side of the airplane would that course be on. In this case, it would have been off on our left, even though here we can plainly see that would be off on our right-hand side. And the to from flag is always going to indicate, again, based on the course that you've selected. So here we can see if we flew in this direction, we'd eventually end up on the bisecting line. That would be going towards it, but it shows from because it's indicating based on the concept that you're going or you're paralleling the same direction that it shows. So if I'm off on one side or the other, the needle will be off. If I'm right on that line, the needle will be centered. Now we often say that as you approach the station, the needle gets more sensitive. The reason being is the distance from a full-scale needle deflection, one side to the other, down here on the gauge, is only 10 degrees one side to the other, from centered. 10 degrees from centered. So if I was on the radial, if I was 10 degrees over to the side, now the needle would be full scale deflected. And you can see that that distance from the centered off to full scale deflection gets tighter and tighter as you get closer and closer. So when you are out here, you can move quite a bit off of the course before the needle really starts to move. But as you get closer and closer, you don't have to move very far at all before that needle is already full scale, hardly moving any at all up here, and that needle is really jumpy. But as you would fly past the station and continue to fly away, the needle would tend to get less and less sensitive, barely moving any as we'd fly away because the radials are getting farther or spread more apart. So it's a little bit about the indications on a VOR receiver. Hopefully it helps you to understand it a little bit better.
And so if I was going that direction, this needle tells us, well, no matter which way that our aircraft is facing here, that needle will tell us our position in relationship to that particular line. Let's take a look at the assignments. There were 3 of them. After the Kahoot challenge on Monday, that was your assignment there, which was doing the dead reckoning questions like we saw last week. The things about like true course, time, fuel, distance. The Kahoot challenge on Monday was just going back through, and those were the FAA questions, by the way, that you had on the Kahoot challenge Monday. So I'll open that back up so you can go back and take those questions. And that would help if you're trying to do the FAA exam, you want to practice those questions, or you're having a little confusion, like give you a chance to kind of work through them. But Tuesday's assignment introduced the VORs, and it said that when you look at a sectional chart, like say here at VFR map, and if we look at a sectional chart, there are different symbols they use to depict a VOR. We usually will see a VOR at the middle of a compass rose. And so if you're looking up here near Tulsa International or down by Okmulgee, you can see those symbols in the middle of the compass rose. And I put in Blackboard a section of the chart legend, so you can go back and you can see the different symbols for those VORs. There's the plain, just plain Jane symbol here, and then there's the Vortac or VOR DME that both have distance measuring equipment available on that. And the videos on Tuesday talked about that. It also talks about the communication box here. So after you look at the individual stations, the assignment says on question 3 here, what other information could you obtain from the VOR label box? And the station's going to have the name of this, or that box is going to have the name of the station. It's going to have the identifier in Morse code. And that's kind of important when you look at these VORs. If we look down here at the Glen VOR, or let's say the Okmulgee VOR, inside that box, it'll have the frequency that you'd put in your radio to use it. And then the whole purpose of the Morse code is so that you can positively identify that you're listening to the right station, that you're using the right station for navigation. So if you don't hear the appropriate Morse code, then either the station's not working right, or you've got it tuned into somewhere else and you've got to go back and check your radio. You want to make sure that you positively identified it before you start trying to use it for navigation. So that was the first assignment. It was just kind of saying like, hey, identify some VORs and use that chart legend to help you to better understand what information is presented in the box. Even things like weather or the flight service station frequencies and things, that's all there. The second assignment, this is Wednesday's assignment. It starts to have you kind of start to interpret a VOR. So looking at it, it said, first, what important step that you have to do before you start using the VOR? And we just said, make sure that you identify the Morse code, that you don't hear the proper frequency, the proper Morse code identifier. Either the station's malfunctioning or you've got it tuned into the wrong one. And then after you've tuned it, you've identified it, then we can start to use our OBS to actually navigate. And this is where the questions say things like a pilot's flying north. Now, it doesn't matter which way you're facing, and this is an important fact. When you try and do VOR navigation, the station doesn't care which way you're facing. You could be facing north, you could be south, east, west. It doesn't care which way you're facing. It's going to show the indication on the needle and that to from flag with no reference to your direction. What it cares about is your location in relationship to whatever you've selected. So if you're flying due north on a heading of 360, it says, what radial is the aircraft located? Well, if it says you're headed towards the station and you're flying north, then where would you be?
Down.
You've got to be south of that station, like it says here, 180-degree radial off the station. Now, radials are listed in the direction that they're located from the station. So if we look at, say, the simulator again, the 180-degree radial would be the line. You'd be south of the station, flying straight north to get to that station. So the third question here said, well, let's draw the airplane that it's facing east going to the station. And in that case, you have to be where in relationship to the station? Well, if you're going east and you're getting to the station, you've got to be west of it. So this is a good picture of that indication. You'd be west of the station flying eastbound. You'd be on what we call the 270-degree radial. Radials are always located or listed in the direction they are from the station, and you're headed eastbound to take you to the station. So laying that down, that foundation, we can kind of finish up the last question on Wednesday's assignment. And this is a long text here, but it says, you become disoriented and you don't have access to GPS or DME. You can only use your VORs in the area to determine your location. So it's saying, hey, you're, say, on this chart somewhere, and you don't know exactly where you're located, but you can see the Okmulgee VOR, you can see the Tulsa VOR on your station. How could you use those to determine your position? Well, the answer here is that you tune one in. Somebody's got a loud mic. You can tune one in and you can center that needle with a from indication, and then you can tune the other one in and center the needle with a from indication, and it'll tell you where you're located. Where those two pieces of information cross, that'd be your location. So if I was looking on the map here and I see the Okmulgee VOR and it said I was on the 90-degree radial, well, that would mean I would be east of that station somewhere. And if the Tulsa International VOR said that I was somewhere, say, 150 degrees, now I could draw a line 150 degrees off that, and where those two radials would intersect, that location would be my position. And that's the way you can do what we call that a cross radial. A cross radial is the intersection of two radials from two different stations, and that helps you to determine your location. So, Sebastian, does that help you out on assignment number 2?
Yeah, it's a little quick and it's a little hard to understand a little bit.
Well, what I will do this coming week is I'm going to put out a few more resources to help you to go back to understand this, but it's a tough subject. And what I told the morning class, and I'll tell you all too, if you're going through these and you're actually trying to understand how a VOR works, it's a little harder to do this in this group setting. I'm more than happy to answer individual questions, even if I need to sit down and have like a one-on-one video chat. I'm more than happy to answer those questions. So let's take a look at number 3 assignment. This is from yesterday. And just going through it as well, it says, referencing the VOR here, the St. Joseph VOR, what frequency would you need to enter to tune it in, and where would we find that piece of information?
Would it be that blue thing? The blue little
box? Communications box, and when you zoom in on that, the 115.5 frequency is what you tune it in. Then after you do that, you identify the Morse code. You know it's working. Now you can twist it in the OBS to navigate or find your position. So if you accidentally entered the wrong frequency, you didn't put that 115.5, we said there'd either be no Morse code or you'd be seeing the wrong Morse code on your station. The next question, I'll bring this one up. It said select the correct indication here, and the correct one out of the 4, the correct one was B. And what I always tell everybody as they do these is draw out the VOR. And so when you're trying to figure these out, you draw it out. So what you do is you draw your station. I don't have any way to annotate this. This one's a little tougher to show off. And so what this is showing, all four of these indications, what they show you is you selected the 360 degree radial. So you've selected a line going north of the station. This one right here, the first one tells you you're right on that line. Okay. Well, the question asks which one shows you that you're northeast of the station. So if you're on that line, you've either got to be north or south of the station. So that's not correct. You're not northeast in that position. The second one, it says that you're that line that goes towards the north is over to your left-hand side, and that'd be the correct one. And I'd have to draw it out to show it. Let's see if I can. Well, I'm going to skip this. I'm going to continue on. I'm going to answer the last questions. Question 9 here. This is the last question on the assignment. And in this case, this one said you've got two VORs, the 355 degree radial from the RBA VOR and the 276 from the St. Joseph VOR. And so what you do is you draw a line 355 degrees from the RBA Robinson, and you draw a line 276 degrees from St. Joseph. And again, that cross radial, where those two points intersect, that's your location. And so in this case, we can see we're kind of right over here over, what is that, Rulo, Mississippi. And I know that's kind of a rough way of explaining all this, but this isn't the optimal way to go through it. So what I'll do is next week, if you're really kind of working on this, you're having a little trouble with understanding how the VOR system works, I'll post a few more videos or a few more resources for you to go back and to be able to work through this and to better understand how that information is presented. But what I'm going to do is kind of move off of this conversation on the VORs and Claudia, I'm going to mute you, okay? All right. So I'm going to kind of move away from the VORs because, you know, it's something that at some point you're going to have to learn how to do, but this isn't the best way to do it. So probably the best way, if you have questions, if you're really struggling with as you go through this, I'll put some more resources. If you watch those, if you're not quite understanding it, then feel free to contact me and I'll explain it a little bit better. So that's kind of it for the assignments. Let me click off here. And I'll stop recording.